All right, so this time we're looking at a metal strip oscillating. Hopefully you can see it here. So again, this thing is basically a speaker wiggling up and down. The post is connected to the speaker, and you can see that metal strip oscillating. And what I'm going to do is I'm going to start increasing the frequency until we see a standing wave. Now, if you want to think a little bit, maybe pause the video and think, once we get a standing wave set up, do you think you will see mixed or matched boundary conditions? Where will you see a node, antinode? How many nodes and antinodes should you see? So again, if you want to think about the nodes and antinodes and whether you have mixed or matched boundary conditions for a standing wave on this strip, pause the video now. I'm going to proceed 3, 2, 1. All right, first let's get a standing wave here. That's a pretty good one right there. Even though this looks a little bit weird, let me go around here so I can point. We see a transverse wave connected to the oscillator. So notice that's going to invert pulses here. So we see this as a node for the transverse wave. And this is an antinode, maximum displacement, right? Obviously, this is being displaced up and down a little bit. But in terms of the reflections of the wave pulses, that's what's inverting it. So this is looking pretty good. Notice we see a node and an antinode. So this length is a quarter wavelength, not a half wavelength. So whenever you have mixed boundary conditions, we see that. So now I'm going to try this again, but I've just mounted this at the center. So if you want to think, how is this experiment going to change when I use the metal strip that's mounted at the center in terms of the nodes and antinodes and all that? So if you want to, you can think about that. You can pause the video. You'll lock this oscillator. So when I pull this out, then I'm going to put the new one in. Now I'm going to unlock the oscillator. All right. And so in this case, it's a little higher. I see a nice standing wave right there. Notice, this is kind of a cool one. Maybe you've been wondering, how could you get a wave generated where you have free boundary here and here? Here's an example of that. Notice the wave is free at these two ends. So we see antinodes at the two ends, and then a node at the center. And so if you think about it now, the length of this is from node to node. Adjacent node to adjacent node is land over 2, right? Well, you can think land over 4 if you wanted to. All right. And then I guess let's just leave it at that. This will hopefully help you visualize whatever problem that was. I'm going to stop the video now. I got a cool demo in the next one you probably are going to want to watch.